doing this a long time at Powercast, doing RF to DC conversion. We've added some additional technologies over the last couple of years, including SmartInductive and also magnetic resonance. What I'm really excited about is looking at the smart home of the future. If you think about needing data to know what's going on in your home, that's going to require hundreds of sensors distributed around your household to tell you, are windows open? What is the temperature? Are the faucets leaking? And right now, those sensors would have to be battery powered. You probably have smoke detectors around your home and you may have 3 or 4 of those, and you change the battery every couple of years. If you have hundreds of distributed sensors around that household, it's gonna become a constant maintenance problem. Where with Powercast, you can have equivalent to like another access point in your house. And that access point is not only getting data from these sensors, but it's also distributing power to them. If you look at the Powercast transmitter, it's very much analogous to a Wi-Fi router that's in your home already. So people understand that technology when it comes to Wi-Fi. They're gonna start to understand that technology when it comes to power as well. Like our cell phone has gone to wireless charging capability. More and more products in the home are going to bring in that technology, whether it's RF for long-range sensor devices or low-power mobile computer peripherals. But MagRes is going to start enabling surfaces inside the home to charge devices. More and more things are going to be enabled with wireless power transfer, and where Powercast is right at the middle of that with all 3 technologies.
When it comes to AI, the limitation of AI at the edge is power. And power is usually coming in the forms of 2 flavors. It's cords and power, wired power, or it's batteries. Both are inherently troublesome for devices at the edge, whether it's the logistics of running those wires, managing that, or the headache that comes with batteries dying or replacing the batteries. So wireless power is the future for AI at the edge. Obviously, we're always integrating our technology into new things, showing demos or actually making end product. 3 very cool new ones are our Bluetooth-based temperature sensor for smart home applications, where it's powered via our traditional technology, but the data comes out via Bluetooth. Gather it right on an app and use that to make decisions about your home environment. We have a similar product, but it's in the industrial space that works with RFID readers. That's monitoring data centers and temperature and humidity in that environment. And then another one in the consumer electronics space is cameras. Whether it's a security camera or a baby monitor, we're doing the powering of those cameras via magnetic resonance. With magnetic resonance, the power source can be on the inside of a wall while your camera's on the outside of a wall. So traditionally you'd run power to that camera, or maybe you'd have it run on batteries, which is a whole headache in and of itself. With magnetic resonance, you can just send the power through the wall. There's a generator unit, and it's simply just a coil of wire. And that generator unit's generating through that coil of wire a magnetic field. And it's not about how I can get power to it, it's more about where do I want it now. In most applications we see, that's mounted maybe under a desk. And then anything that exists inside that loop of wire is inside the magnetic field. And we put our receiver device on it, and then anywhere you move your device inside that loop, you're getting power. So it takes that Qi-based inductive charging to the next level, where you can slide everything around any way you want on that desk. And it's significant amounts of power. And even one step further, you actually get some Z-height separation as well.
The distance that we can power a device really depends on how much power it needs itself. If it's a higher power device like a game controller or something like that, that's more a kind of countertop or desktop type charging area with your 1 or 2 feet away from the transmitter. But when you start to get into wireless sensor devices that need microwatts of power on average, we've powered sensors as far as 200 feet away from one of our transmitters. And every day our R&D team's working on expanding our capabilities, improving our sensitivity to drive that range farther and farther.
The number 1 question we get at every trade show is, well, can you power my smartphone? And the answer is yes, I can do it in any way with our 3 flavors of wireless power. The number 2 question I always get, specifically about the RF side of things, is it safe? And I always say the same thing to the people that ask that is, if you're comfortable using a cell phone, taking calls with it, our technology is orders of magnitude lower. The exposure is so much less.